Hello guys, welcome to Apex Math. My name is Pino. In this video, we'll be going through question 1 from the April 2025 N5 question paper. Question 1.1, we have to determine the limit of tan x minus x all divided by x minus sin x as x approaches 0. And from here, we directly substitute the 0 where there is the x, and we have tan of 0 minus 0 divided by 0 minus sine of 0. And tan of 0 is equals to 0. And we still have the minus 0. And we have 0 minus sine 0, which is equals to 0. So we have 0 minus 0, which is equals to 0, divided by 0 minus 0, which is equals to 0. So we have the indeterminate form 0 divided by 0, as we know that division by 0 is not allowed. So we are going to use the L'Hopital rule in order for us to determine this limit. With the L'Hopital rule, we differentiate the top and the bottom, the numerator and the denominator separately, and it must not be confused with the quotient rule. So we have y is equals to the limit as x approaches 0 of the derivative of the top part, the derivative of tan x minus x. The derivative of tan x from the formula sheet is equals to sec squared x and minus the derivative of the x, which is equals to 1. In the denominator, the derivative of the x is equals to 1 minus the derivative of the sin x, which is equals to cos x. Remember that the L'Hopital rule must not be confused with the quotient rule. So from here, we substitute directly 0 where there is x, and we are going to have sec squared of 0 minus 1 divided by 1 minus the cos of 0. The sec squared 0 can be expressed as 1 over cos squared 0 on the calculator, and it will be equals to 1 minus 1 divided by 1 minus cos 0. Cos 0 is equals to 1, and this will be equals to 1 minus 1 is equals to 0. So once again, we have 0 divided by 0. We have to use the L'Hopital rule again. So we have y is equals to the limit of the derivative of the top part, the derivative of the sec squared. We can write the sec squared x as equals to sec x all raised to the power 2. So when we differentiate this, we have the 2 from the exponent multiplied by the inner function, the sec x, and we minus 1 from the exponent, and we differentiate the inner function, and the derivative of the sec x from the formula sheet is equals to sec x multiplied by the tan of x. So this is equals to 2 sec x multiplied by sec x multiplied by the tan of x. So the derivative of that sec squared x, we determine it to be equals to 2 multiplied by sec x multiplied by sec x multiplied by tan x, and the derivative of that negative 1 will be equals to 0. And now we differentiate the denominator separately, and the derivative of that 1 will be 0 minus the derivative of cos x, which is equals to negative sin x. This is as x approaches 0. Now we have y is equals to the limit of 2 multiplied by sec x multiplied by sec x is equals to sec squared x multiplied by tan x, and negative multiplied by negative will be positive, and we have positive sin x, and as x approaches 0, we have y is equals to the limit of 2 multiplied by sec squared x, but we change that tan x and we write it as sin x divided by cos x. We change the tan x and simplify, because if we were to directly substitute the 0, we will still get 0 divided by 0, meaning we have to use the L'Hopital for the third time. And that sin x in the denominator, we express it with this division sign. So we divide by that division sign, and our y will be equals to the limit of 2 multiplied by sec squared of x multiplied by sin x divided by cos x, and we change that division sign into multiplication sign, and when we do that, the sin x divided by 1 will become 1 divided by sin x, and our y will be equals to the limit. So we have this as x approaches 0. So as x approaches 0, so we have the limit of 2 multiplied by sec squared of x, and that sin x and that sin x will cancel out, and we still have that 1 over cos x. So we still have 1 divided by cos x as our x approaches 0, and we have y is equals to the limit of 2 multiplied by sec squared x. Remember, 1 over cos x is equals to sec x, so that 1 over cos x, we write it as sec x as x approaches 0, and we have y is equals to the limit of 2 multiplied by sec squared x multiplied by sec x, which is sec cube x, as x approaches 0. Now we directly substitute and we drop the limit, and we have 2 multiplied by the sec cube of 0 where there is x, but the sec cube of 0, we write it as 1 divided by cos of 0 raised to the power 3 on our calculator, and it will be equals to 1. So we have y is equals to 2 multiplied by 1 divided by 1, which is equals to 2. So our y is equals to 2. Question 1.2, we have to determine the values of x for which f of x is discontinuous if f of x is equals to 3 divided by e raised to the power x squared minus e to the power x. Remember that a function can only be discontinuous if we have a square root of a negative number, or if we have division by 0. In our case, we don't have any square root, but we have division. So this will be discontinuous when the denominator equal 0. And the instructions said that we have to determine the value or values, meaning that we can have more than one value. So we'll have e raised to the power x squared minus e to the power x equals to 0, since division by 0 is not allowed. And we take the e to the power x to the right, it will change sign to positive e to the power x. Remember that in this case, when the bases are the same, then it means that for this equation to be balanced, the exponents also have to be the same. So we have x squared equal x, or rather we can use the logarithmic law, which states that the ln of e raised to the power a is equals to a. We can introduce ln both sides. So we have the ln of e raised to the power x squared. What we do on the left, we do on the right. So even on the right, we have the ln of e raised to the power x. And this, according to that law, will still be equals to x squared is equals to x. And we are not going to divide through by x. We take the x to the left, it will change sign to negative x, and we take x as our common factor. And x will be into x minus 1 is equals to 0. X will be equals to 0, or x minus 1 will be equals to 0. And our x in this case will be equals to 1. So we have x is equals to 1 and x is equals to 0. This means that if we were to substitute x is equals to 1 or x is equals to 0 in the denominator, that denominator will be equals to 0, and division by 0 is not allowed, so our function will be discontinuous. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like and share the channel if you find this content useful.